I would like to welcome you all for this very insightful webinar, which is on 6G technology. Actually, first of all, I would like to welcome today's keynote speaker, Dr. Anuradha Mendis from University of Agdenovi. And also, I would like to welcome our chair of the Electrical, Electronic and Telecommunications Engineering Sectional Committee, Engineer Sahara Masuk, and all the participants, engineers, dear ladies and gentlemen. Actually, we all know that technologies are rapidly evolving. 6G is one of those. As we heard and as it is expected, we can consider 6G is sort of a paradigm shift in terms of lots of merits associated within it. Actually, 6G can be considered as very evolving technology, which advanced not only in telecommunication engineering, but also electrical engineering and some other fields as well. So it is sort of a very rapidly evolving technology. To learn more on this 6G and how 6G technology is multidisciplinary, interact with other fields, as the Electrical, Electronic and Telecommunication Engineering Sectional Committee, we have invited a guest speaker or a keynote speaker who is very sound in this area. First of all, I need to extend our sincere thanks to Dr. Anuradha for your kind acceptance of our invitation and to be the keynote speaker for today's session. So before just moving to the your public lecture today, I would like to introduce our keynote speaker to the audience. Dr. Anuradha Mendis is our keynote speaker today, and he is an assistant professor in the Department of Information and Communication Technology, University of Agder, Norway. He received his BSc Engineering First Class Honours degree from the University of Ruhuna, Sri Lanka in 2008. And his MSc and PhD degrees in ICT from the University of Agder in 2012 and 2016, respectively. His master's thesis was awarded as Best Master's Thesis in ICT at UIA in 2012. From 2017 to 2020, he worked as a postdoctoral research fellow at the same university. Dr. Mendis has extensive experience in wireless communication, focusing on spectrum allocation, reliability and performance evaluation using stochastic process modeling and statistical methods. He has contributed to several international research projects, including serving as a research engineer in the Solid B5G project, which focused on beyond 5G, IOV, V2X, and maritime services. He has industry experience as an engineer at Huawei Technologies, Sri Lanka, and worked as a senior lecturer attached to the Department of Electrical and Information Engineering, University of Ruhuna from 2020 to 2022. He is a senior member of IEEE and has also served as a session chair for IEEE conferences, as a technical program committee member for multiple international conferences. His current research interests include 5G and 6G networks, massive MTC, IoT, applied machine learning, and modeling and performance analysis of communication systems and networks. Dear engineers, ladies and gentlemen, we have invited such a prominent speaker for today's webinar today. So I think it is no need of waiting of more. Over to you, sir.
Okay, thank you very much, Dr. Konara, for your kind introduction. And I am also honored to have this opportunity to deliver this webinar on 6G, the future wireless technology. Okay, good evening, everyone, even though it is still afternoon in Central European time. And yeah, first of all, I'm going to apologize in advance if due to my voice today, because I have some cough conditions a little bit. So I hope it will not affect for the webinar quality. And yeah, let me share my screen. I hope you can see the screen now. So today I'm going to discuss about 6G, the future wireless technologies. The main issue here is today I'm going to talk about something which is not realized yet, and even not standardized yet, or even not finalized any specifications. So whatever the things that we are going to discuss today, uh, subjected to change in the future, because 6G is going to be deployed after 2030. So, but research is going on in order to ensure that we can guarantee whatever the 6G performance indicators after 2030. Okay, so this is the outline of my presentation. So I will introduce 6G as a future wireless technology first, and then we will look at why we need 6G. Still 5G is on the deployment phase, so why we have to talk about 6G. And what are the 6G spectrum and frequency bands? What are the candidate spectrum that we are going to looking at for future wireless techniques? And what are the 6G enabling technologies? So I may not able to discuss all the technologies, but the most important techniques we can discuss. And most importantly, what are the paradigm shifts in 6G? When it comes to 4G, 5G, there are many similarities, but there is no very big paradigm shift in 5G according to my view. But I hope 6G will have some paradigm shifts. So what are they? And finally, I'm going to focus on some 6G research progress in Europe. Okay, so so this is the next generation wireless technology we expected around 2030. Even though we expect 5G around 2020, but still it is not realized in many countries except Europe, United States, Japan, South Korea. The well-developed countries have this 5G deployments now, but not many countries. So it aims to improve speed, coverage, and reliability. So these three performance indicators are the most important parts in 6G: speed, coverage, and reliability. So beyond 5G, uh, how we can improve these three performance indicators in 6G. And this is driven by increasing data demand and new applications. So compared to the 5G applications, 6G applications will be different. So new applications will be emerged in the future. So we will talk about those things. And there is a integration of digital world, physical world, and human world in in the future wireless technologies. So this seamless connectivity and ubiquitous connectivity and anytime, anywhere, anything connectivity, those are the key words behind this digital, physical, and human world uh, cooperation in communication. So we are going to discuss about these things in the next few slides. Okay, so before going to discuss about 6G era, we can little bit pay attention on very briefly what are these generations. So we are currently in 5G generation or 5G era, and actually we have passed 4 generations. From 1981, we had first generation networks that is only for phone calls. So most of us did not realize these things in 1981, but when it comes to 1991, we have realized the 2G mobile communication systems. That means GSM basically. And with 2G, we can, in addition to the phone calls, we could have some messaging and also global roaming. So in order to support global roaming, every country has to be agreed with these standards. So that is very essential. So even in 5G, 6G, those wireless communication standards should be followed by every operator, every vendor, every country. And in 2001, we could have third generation with low speed data transfer and the telemetry applications with 3G, and we could have video calls for the first time after 2001. And with 4G, the mobile broadband concept came. So we can download very big files, even films, and we can stream videos. So these kind of the huge enhancement compared to 2G and 3G came with 4G. So compared to different generations, I feel 4G has kind of a paradigm shift, but not fully. But it's a major enhancement. And after 10 years, 5G era came. And in 5G, we are going to deploy fixed wireless access and mainly Internet of Things and massive machine type communication and critical communication. For example, if you want to implement vehicle to vehicle communication, V2X scenarios, or remote surgeries, this kind of critical communication applications introduced after 5G. And what is in 6G? So we have to discuss it. And you can see each generation has roughly 1 decade of period. So that's why we expect 6G will be deployed at least uh, not in very widely deployment scenarios, but at least in just commercial, some of the commercial deployments in 2030. So this from voice calls to critical applications, we had a very long journey like this. And in 6G, we aim to integrate all these applications into a kind of one unified network. So that is the target. So with the introduction of these generations, you can see how this data rate increased compared to the previous generations, and latency is going to be reduced generation by generation. So in 2G, we had 300 millisecond latency for many applications, but in 5G, we expect 1 millisecond latency for critical applications. And in 6G, we plan to have microsecond latency for critical applications. And data rate, we expect 20 gigabits per second in 5G, which is not achieved practically yet, but in 6G, in terabits per second range is expected. And yeah, there are many performance indicators in terms of mobility support. That means in 5G, we expected 500 kilometers per hour speed. User equipment will not disconnected due to that speed in 5G. So in 6G, we expect it more than 1,000 kilometers per hour. But to be honest, these are the upper bounds. So we don't expect this much of performance in 5G or 6G, but some moderate values compared to these performance values. And the most important thing that I want to highlight here is in 2030, these mobile communication networks rely on, a major part will be rely on artificial intelligence. So still until 4G, AI techniques, machine learning techniques are not widely used in communication networks, but it has started to leverage machine learning in 5G, but in 6G, it will be an essential part. So when the generations are evolved, the cellular networks also evolved. So in the first generations, we can have one network per one application. For example, so if you want to hear FM radio when you are driving, then there is a separate network for that application. And for your mobile calls, there is a separate network. But when it comes to 4G, 5G time, so we have one network for all these applications. But that is not the end. So now in 5G advanced time, that means in 2025, we are going to deploy network slicing practically. So that means the same physical network, we are going to virtually divide it into virtual networks that will fit with different applications. For example, for critical applications where the latency is a problem, like less than 1 millisecond latency, then we can allocate resources for achieving that objective only. So in that network slice. And if you come to Internet of Things slice, then the main concern is the power consumption of devices, because those devices doesn't need very high data speed. So they are expecting very low power consumption and very small packet communication. So therefore, some different resources should be there. So this network slicing concept is the main virtual network concept that we are talking today. So in 5G, we have three major scenarios. Enhanced mobile broadband for very high data rate applications, and massive machine type communications for Internet of Things, and ultra reliable and low latency communication for, again, for critical applications. So these three main usage scenarios are introduced in 5G. On top of these three scenarios, there are many applications generated we can think about. So to achieve these objectives, or to achieve the performance of these use cases, we have several technologies introduced in 5G, and those techniques are not widely used in 4G. For example, millimeter wave communication. Even though millimeter wave communication is not a successful story, but still we believe that in the future, this millimeter wave communication will provide ways to achieve the 5G targets. And massive multiple input output, so massive MIMO techniques, they are very important to achieve 5G targets. Especially we want to have this enhanced mobile broadband. So then massive MIMO is an inevitable factor. And ultra dense networks. That means in 5G, we have very small cells because of one reason is we are going to use these higher frequency bands, millimeter wave bands, and then we cannot reach far away. So then our cell size become very small, and therefore we have a lot of networks we have to deploy in a geographic area compared to 3G and 4G techniques. Okay, so some people say 5G has been a disappointment, but many researchers and many academic people partly agree with this, but actually, is it true? Is 5G is a disappointment? So I can tell you 5G has been largely successful in terms of many objective metrics, but even though 5 years has passed from the beginning of 5G time, it is still in early stages. So we don't know in the next 5 years how the global communication deployments will be there. But currently, roughly half of the operators who deployed 5G is in a non-standalone mode. That means they are using 4G core network. There is no separate 5G core network. And 4G signaling carriers are used for 5G. Therefore, we call this is not a fully 5G, but non-standalone mode. And standalone mode, we are expecting 5G's standalone mode in near future. There are few deployments in United States and Japan with 5G standalone. So real 5G experience we can achieve with this 5G core network. So maybe that is one reason why we call or why we tell that 5G is a disappointment until now. And slow rollout of new verticals. So we expected new verticals, new applications like remote surgery will be facilitated by 5G, but uh, none of the operators could facilitate those verticals until now. And one major reason to have 5G kind of disappointment is this millimeter wave band, because I heard recently South Korea deployed and they invested huge money for millimeter wave communication, but suddenly they have to stop all these projects because they realized the millimeter wave communication will not help with this standards or with these techniques because of high penetration loss and this very small coverage area. So engineers or researchers now try to avoid millimeter wave deployments in even in those big countries. And the other reason is 5G power consumption. So in this slide, you can see 5G power consumption will be very high compared to 4G, 68%, even though the power consumed in 5G networks to transmit 1 bit is very less compared to 4G, but the total power consumption is very high. So one reason is the cell sizes are small. So therefore, we have to deploy many cell sites. So then it consumes much power totally. And massive MIMO technique need a lot of antennas in base station site. So this it has very high power consumption, then you can guess it. So therefore, this power consumption and cost is one reason. And all 5G requirements will not meet in 2030 definitely because of these problems. So that is why we are going to search for kind of paradigm shift in 6G, as I mentioned earlier. So definitely 5G cannot handle this current traffic demand. If we expect this traffic growth rate in this way in 2029, you can see most of the traffic demand for is for 5G, not for 2G, 4G networks. So while this 2G, 4G traffic demand decreasing, 5G traffic demand increasing. So Ericsson tells that this traffic doubled every 4 years. So in order to support these applications, especially IoT applications, automation applications, and integration of AI techniques into these communication networks. So we need to have more, uh, uh, we need to have some new techniques to adopt these things. So as I mentioned, 5G will not meet all requirements in 2030. So we need very high time synchronization and phase synchronization accuracy in order to meet the 6G applications, which I am going to tell you just now after a few slides. And we expect 100% coverage and ubiquitous coverage in all over the world, not only ground, but maritime communication and satellite communication. Everything will be connected in 6G time in order to provide this 100% coverage. And we are dealing with 2D videos and virtual reality, AR, this kind of applications. But in the future, when we have the developed AR, VR techniques and 3D video, maybe you heard holographic communication. So that kind of applications need terabits per second level transmission rate. So current 5G techniques may not provide that much of transmission rate, definitely. And also this artificial intelligence enabled smart applications. So these are the things that we push towards a 6G communication time. So in 5G, we had a lot of new requirements than 4G. For example, massive MIMO and massive machine type communication, ultra reliable communication, and very accurate positioning. But we have to expand these performance indicators, or we have to tight these indicators in 6G. For example, in URLLC, 1 millisecond latency, we have to tight as several hundreds of microsecond latency in some critical applications. And we have to think about spectrum flexibility. Still in 5G, we are not considering dynamic spectrum sharing much, even though this topic is a hot topic for a long time, but they are not actually utilizing spectrum flexibility fully in 5G networks. And terahertz waveforms is a hot topic. There are European projects going on specifically focusing terahertz communication, even though millimeter wave communication is a disappointment, but they have not abandoned these topics yet. And there are many things in 6G to support radio performance increasement, sustainability, and trustworthiness by using security concepts, enhanced security techniques, and yeah, global service coverage. So these are the things in 6G. And these are the key applications in 6G which is not available in 5G yet, like self-driving vehicles and brain-computer interfaces, how your brain will interact with some computer interfaces. I don't think this will be possible even in the first time or first few years of 6G. But this industrial automation, self-driving vehicles, global coverage, radar sensing, how you're going to sensing objects while you are in real communication. So these kind of things are real applications in 6G. Okay, so let me briefly tell about 6G development process now. So you can see this ITU, International Telecommunication Union. They are the basic body that sets requirements for 5G and 6G even. And in mid 2023, ITU radio communication sector published the first draft framework for 6G, IMT 2030. IMT 2020 is for 5G, but this is for 6G. And then 3GPP, the third generation partnership project. They are the responsible organization who develop specification based on the ITU requirements. And once the ITU and 3GPP finalize these requirements and specifications, the research institutes develop these enabling technologies. And these research are going on from 2018 or 2019, even before starting 5G. And you can see after release 21, 3GPP release 21, we are in the 6G time actually. So after 2028, 6G spectrum will be decided, 6G specifications, all the 6G related things will be finalized, and 2029, 2030, the deployment scenarios are going on. Okay, so yeah, as I mentioned earlier, in 6G, the 5G requirements are tightened, and also new requirements are generated. For example, AI and communication, ubiquitous connectivity, and integrated sensing and communication. So these are the new things in 6G, but this mobile broadband and URLLC, massive communication, they are still with high requirements. And yeah, these are the new capabilities in IMT 2030, which is not available in 5G. Positioning, indoor positioning is a hot topic today, at least in academic areas. So how we going to have positioning, indoor positioning less than 10 centimeters accuracy? So people are searching many techniques with 5G signals and Wi-Fi, 5G equivalent Wi-Fi signals. That kind of solutions are there, and coverage enhancement. So these are the new capabilities. But these green color capabilities still we have in 5G, but in 6G we have more requirements for these things. For example, as I mentioned, reliability in 5G is 0.5 zeros and 0.95s, but here we need 0.79s, like that. So the candidate spectrum band for 6G will be the lower mid-band and upper mid-band. So currently we are using lower mid-band, this 3.5 gigahertz band for 5G, and very high frequency band, 28 gigahertz for millimeter wave communication in 5G. So in between these two bands, this upper mid-band is remaining. But for 4G, 3G, 2G networks, they can't use this band. So I think this is the ideal candidate for the 6G communication, the upper mid band. So one reason is it is not going towards the millimeter wave, but less than millimeter wave. So we can balance between the coverage and the data speed. Coverage and data speed. So if you want to use millimeter wave, then our coverage is limited. If you want to use lower mid-band, then our data speed is limited. So there is a trade-off between these two performances. So therefore, okay, maybe you know this lower mid-band and this millimeter wave bands are named by 3GPP as FR1 and FR2. And then this upper mid-band, the between these two bands is going to be named as FR3, frequency range 3, that is for 6G. And there are another three bands you can see, this 4 gigahertz and 7 gigahertz and 14 gigahertz. So there are three bands which are available as candidate bands for 6G communication. And higher frequencies, for example, terahertz range frequencies, we can still used in 6G, but for very extreme speed requirement to fulfill that kind of requirements and very high precision in positioning that kind of applications. Otherwise, for normal 6G communication, we should not use this high frequency bands. And this lower mid band still is very popular among researchers and this 3GPP specification makers, because this band is very suitable for achieving 10 times capacity increase than 5G. Compared to 5G, we need 10 times capacity achievement in 6G, because in order to achieve terabits per second range, so then lower mid band will be a very good solution. Okay, so these are the different applications in 6G. So based on the 6G application, we can use these different bands. For example, if it is a capacity hotspot that we want to cover some stadium event like a football match, or if you want to cover a sudden incident, that kind of hotspot application, we need millimeter wave. Otherwise, for having capacity, 10 times capacity increment, maybe this 7 to 16 gigahertz band or 3 to 4 gigahertz bands are optimal. And for IoT applications in 6G time, we can have this very low frequency ranges, because we want kind of coverage in IoT applications, not a very high data rate. Okay, in this slide also you can see, based on this upper mid band, lower mid band, or millimeter wave communication, our coverage, how it varied. So in lower mid band, we can have few kilometers, but upper mid band, the kilometer range coverage is not possible. And with terahertz, it's less than 100 meters. So will millimeter wave actually be used in 6G? Since 5G, it is a disappointment, and many operators try to remove millimeter wave deployments. So can we have this in 6G? So this is a huge debate, but actually due to this penetration losses and coverage limitation, that is the main reason that we cannot have this millimeter wave performance. But in 6G, researchers suggest some integrated techniques with the millimeter wave. For example, enlarged antenna arrays and beam tracking and prediction and precise beam alignment. Excuse me. So these techniques can improve millimeter wave performance. So just having a millimeter wave frequency spectrum and millimeter wave antennas will not help to achieve the target. So we need some beam alignment or beam prediction by using machine learning, and then we can narrow down the beam towards the target from the base station, then we can achieve that performance level. So these are the 6G enabling techniques. So in terms of multiple access techniques, 6G is going to be it will use NOMA, non-orthogonal multiple access. So in 2G time, we use TDMA, FDMA, and 3G time, we use CDMA, and 4G time. And also in 5G, we use OFDMA, orthogonal frequency division multiplexing techniques. But here, we are going to use NOMA, non-orthogonal multiple access. But indeed, NOMA is proposed in 5G advanced. That means the later stages of 5G. So I hope this will continue with 6G. And I'm not going to tell about more details regarding NOMA, then it will take a lot of time. But yeah, we will go to next enabling technique. So dynamic and intelligent spectrum sharing, which is not widely used in 5G, will be used in 6G. So the spectrum sharing is very important due to limited spectrum resources. As I mentioned here, this upper mid band will provide, even though it is 7 to 24 gigahertz, very big band, but they are not planning to utilize all bands in this upper mid band. So there are several frequency ranges they are going to use for 6G. So in that case, still spectrum resources may be limited in 6G. So then how we can share the spectrum, because we know that currently these operators, they have license for this radio spectrum, uh, and they are renew these licenses maybe every year by paying a lot of money for the telecommunication regulation bodies in their countries. And then sometimes these spectrum bands are not fully utilized by the operator. So therefore, when the license spectrum is not fully utilized, so it is a wastage. So when the primary user is not utilizing the spectrum, secondary users may be able to access that spectrum. So in that case, there should be a agreement between primary user and secondary user, kind of spectrum leasing or spectrum auction. That kind of concepts have discussed earlier. So we can have this cognitive radio concept in 6G networks to improve the spectrum efficiency. And AI support is very important in dynamic spectrum management. How you're going to dynamically allocate channels, spectrum for these primary, secondary users. So this is a hot topic. And beyond spectrum sharing, network equipment sharing is another important direction. Not only the spectrum, but how about we share network equipment among operators, among different networks. For example, in United States, these operators share macro cell towers. So, for example, the American Tower, Crown Castle, this is famous example for this operators sharing macro cell towers. And I will talk about this network equipment sharing later a little bit. And so this is another enabling technique in 6G, the blockchain-based wireless access. So this is actually not adopted in 5G networks. So, but there are a lot of discussions going on. How we going to integrate blockchain-based 5G or 6G networks? Uh, but there are a lot of uh, challenges. For example, if we use blockchain-based mechanisms, the latency will be higher because if you have any idea about blockchain, you know that blocks should be generated, and then block generation time is there. And to send these blocks all over the distributed network, there is a propagation delay. So these are the additional delays introduced with the blockchain. And there are some scalability problems, the block size limitations, and what is the maximum number of transactions per second that we can have in blockchain. So, and network bandwidth storage should be allocated for these the blockchain data storage. So there are some kind of scalability and latency and integration complexity issues. So even though blockchain will be a very high secured and highly efficient mechanism that we can adopt it in 6G, so we have to face to these challenges. And self-free MIMO is another hot topic. So I can introduce this concept by using this figure. So the Swedish professor Emil Björnsson is very famous for this self-free MIMO technique introduction. He has written one even book, and many papers. And what he suggests is currently we have MIMO networks, multiple input, multiple output. So many antennas will be supported for MIMO communication. And here we have a cell boundary that cover by these antennas. But in 6G, we expect we have cell-free network. That means uh, one mobile user equipment can be covered by different MIMO antennas, but there is no specific cell coverage because these antennas are connected to a central processing unit, CPU, and then CPU will manage or coordinate different antennas to provide the best or the optimal communication towards the user equipment. So this concept is a little bit similar to the concept introduced in 4G networks. Maybe you heard about joint transmission and reception. That means, but however, in 4G, this concept introduced only for cell edge users, the users who are not covered by any base station because they are in the cell edge, but still base stations can cooperatively uh, do something and then give the best signal towards the cell edge user. So similar to that concept, cell-free massive MIMO concept is introduced. So in this case, you no need to worry about your coverage. Once you are with kind of MIMO uh, antenna coverage, then these antennas will be coordinated via a central processing unit and cover you. And this will be a technique for 6G. The other thing is radio stripes, which is tested in Ericsson, Sweden. And this is similar to this cell-free MIMO technique, but deploying many antennas in this in a particular geographic area is difficult because of line of sight, that kind of issues. So they introduced this radio stripes concept for 6G. So still we have a central controller which cooperate or coordinate all these radio stripes. We call, actually these are antennas, and then we can cover hotspots areas, for example, a stadium and the very densely populated areas with these stripes, antenna stripes in the buildings. So it can give you millimeter wave performance to the users in specific applications. And theoretically, they have tested these radio stripes, and you can see the spectral efficiency is very high in these yellow color places, and in blue color places spectral efficiency is lower. So this is traditional MIMO, and when it comes to radio stripes, you don't see any blue color places here because the stripes can increase the spectral efficiency than traditional 5G MIMO techniques. And reconfigurable intelligent surfaces. This is a new concept introduced for 6G. I don't think this is possible in even in 6G first few years. So here the concept is similar to relaying technique, but actually these are not relays. These are intelligent surfaces which has these passive or active elements, where the main transmitter, when the main transmitter sends something to the receiver, if the receiver is blocked by some kind of obstacle, then this RIS surface can redirect that signal towards the receiver by changing this incident signal's phase angle, or because they have phase shift circuit. And also, if it is an active RIS, it can amplify the signal. If it is a passive RIS, then just change the phase shift and send the signal towards the receiver. So by using these reflected surfaces, so we can deploy these RIS surfaces in town areas where a lot of buildings are located. So then the obstacles will not be a problem for receiving the signals towards these mobile phones. And these are like test beds uh, deployed in Sweden, or I think it's in Finland or Sweden. I'm not sure. So, but in this research paper, uh, they showed that with RIS surfaces, we can achieve a greater spectral efficiency. So this is the CDF, or cumulative distribution function. So we can see if we want 6 efficiency, 6 bits per hertz bits per seconds per hertz. So we can reach it with this RIS concept. But you can see this curve, the pink curve is not only RIS plus static path. That means you should get some kind of line of sight or non-line of sight signal to the receiver and the RIS signal. So if you receive both, then you can have better performance. Only RIS signal will not give you best performance. So therefore, this concept is a very interesting concept, but it has a lot of things to be developed. And then UAVs for 6G. So I don't want to tell about UAVs. Everyone knows in 6G, we are going to use UAVs for different applications, not only as a base station, not only as a flying base station, but as a relay or data collection purposes or energy harvesting. So there are many purposes that you can use UAVs in 6G. And Open RAN is the main RAN development, radio access network development in 6G. So even now, Open RAN is deployed in several countries. For example, so these Vodafone and Telefonica, the big operators, are agreed to deploy Open RAN in their sites. So in Open RAN, what is the concept is that they are built on disaggregated and virtualized software-based elements in radio access network. So they are going to separate these baseband units and radio units in conventional traditional RAN networks into central units, distribution units, and radio units. So the operators don't need to depend only on a one vendor uh, like today, because if you, for example, Mobitel Dialog operators take Huawei equipment in BBU, so you cannot replace it with another vendor's software because they are not compatible each other. So in Open RAN, the software hardware, they are decoupled, and we can integrate any vendor software with any vendor's hardware. So therefore, there is no difficulty in 6G if we have this Open RAN concept. So the main thing is we need machine learning here, because this RAN intelligent controller, which is mentioned here, RIC, is going to coordinate these different vendors, software and hardware uh, management. Okay, so then in order to achieve this 6G coverage, as I mentioned, spectrum sharing is an important part. So how you going to share different spectrum in different RAN configurations? So that is an interesting question. So this innovation, energy efficiency, and reduce complexity and resiliency will be achieved through this Open RAN in 6G. So all over the world, 23 mobile network operators now they are agreed on Open RAN deployments. And these are the paradigm shifts in 6G that I want to highlight today. There are 4 paradigm shifts which is not available in 4G, 5G. So first one is space, air, ground, sea integrated network. So we are going to have one network or integrated network by combining satellite communication, drone communication, and traditional terrestrial ground communication, as well as maritime communication in the sea. So this is achieved in order to provide ubiquitous wireless communication globally, because 6G need 100% coverage. So that means anytime, anywhere, anything coverage. So in order to achieve that concept, you need satellite communication, drone, and maritime communication. But there are some integration issues because we have uh, operation and management problems when we have to integrate these communications, and what are the best routing strategies. For example, when we use satellite or drone communication, how you going to route those traffic into the terrestrial communication. And energy efficiency is a problem because drone communication is not energy efficient until now. And yeah, the promising solution to solve these things are SDN based, that means software defined networking based, hybrid and hierarchical network control structure. So then, since there are hierarchical network control structure, we can integrate these communications by using software defined networking concept and achieve our target. And next one is all spectra integrated network. That means in 6G, as I mentioned earlier, we are going to use upper mid-band and existing lower mid-band and millimeter wave band. And beyond millimeter wave, we are thinking about terahertz communication and sometimes optical communication. So these things will be integrated in 6G. And intelligent networks, so machine learning. So this is the hot topic. So intelligent 6G networks, these are the hot research areas currently. So how we going to allocate radio resources intelligently, and when it comes to Open RAN, how we are going to manage the radio access network. So how we can automate network management by using AI techniques. And edge computing, how we going, edge computing is still here in 5G, but how we going to apply distributed intelligence concept for low latency applications. And security and threat detection. We can improve this threat detection by using machine learning detection techniques. So these are the challenges to achieve this machine learning applications in 6G. The first one is computational overhead. So in 6G, massive number of devices, users are engaged, and gigabits per second or terabits per second range data. So there is a very huge computational overhead. So in order to achieve best performance, these machine learning algorithms need very large data sets. So how you going to assure the privacy of this data, because these data belong to users equipment, so privacy is a big concern. And in 6G, it is really ultra dynamic environments. Even you move from one home to another home, or one office to another office, near office, your cell may be changed because small cells. So then real-time adaptability. So machine learning techniques should give you best performance by adapting to these dynamic changes in your network. So these are the challenges in machine learning in 6G. And I can tell you about, okay, I think I missed one point, the security. Yes, one paradigm shift is network security. So the main concern is this data security, because since we are going to use AI techniques, so the database is a huge database in 6G. So uh, an open RAN is there, so different vendors software and different vendors hardware are integrated, and then there are some security issues with this data sharing. So there are new security issues coming into the scenarios. So definitely, the traditional cryptographic methods will not be helpful to tackle those security issues. So we need some uh, not only like higher layer security mechanisms, but physical layer based methods will be welcomed in 6G. Okay, and also quantum based methods. So if you use quantum based security, uh, we can improve the security level uh, maybe 100 times. So that is expected. And blockchain based methods we can utilize uh, instead of these traditional cryptographic methods. Okay. And 6G research progress. I think I have covered many techniques that we can use in 6G. And by using these techniques, 6G research is now going forward to the 2030 time. So the first research attempt was done by University of Oulu Research Group. They have separate 6G research group, and it is 2018. And first 6G Wireless Summit was held in Finland because of University of Oulu Research Group, and it is successfully finished 2019. And in 2019, the same year, the European Union launched a 3-year 6G basic technology research project for the physical layer to find out what are the best physical layer techniques we can use in 6G communication. So what kind of modulation. So I think during these projects, they came to some conclusions. We need 1024 level QAM modulation techniques. Uh, that means very high level modulation techniques. And the European Union has also initiated terahertz research project. Because of this millimeter wave disappointment, they are looking at how we're going to improve millimeter wave and terahertz communication in the future. So in this slide, you can see there are many research projects started to find out solutions for 6G communication. The HEXA-X project is spending a lot of money for developing 6G techniques. So in this project, as I mentioned earlier, these three worlds concepts are going to be coordinated with each other: digital world, physical world, and human world. So IoTs and the society become more digital. We call digitalized society. That means society and the industry, they are going to be use automated techniques. So then uh, IoT networks will help to achieve those targets, and then human. So they are testing how they can achieve this trustworthiness and sustainability and inclusion principle in 6G in considering different directions. Okay, then interestingly, I found the 6G patent applications. There are thousands of 6G patent applications came now. So most of the applications are from China because in terms of companies, Huawei is the leading company who has a lot of 6G patents now. And compared to United States, China has a lot of patents. And Qualcomm, Samsung, Nokia, they are the leading technical companies who started these research activities for 6G. Okay, my question is, will 6G be backward compatible with 5G? Because in Sri Lanka, I know still there is no proper 5G development yet, even though 2020 has passed now 5 years. But there are a couple of pilot projects by Dialog and Mobitel, I heard, and they have already deployed some small scale 5G base stations. Even I heard Mobitel has standalone 5G deployment for covering for some testing purposes. So, however, I expect by 2030, Asian countries can have developed 5G standalone uh, sites. Maybe 6G will be delayed. Uh, but until that, can 6G be backward compatible with 5G? So that is an important question. Although we know that when it comes to 4G passing 3G, there is no backward compatibility. There are a lot of issues. Your uh, your 2G phone is not supported for 4G phone or 3G video call. So there are a lot of issues with this compatibility. But as the future generation technique 6G try to deploy as much as backward compatible with 5G networks. So therefore, it allow most 5G deployments to continue work through the 6G networks. But there may be some 5G features will be dropped in 6G. For example, this power saving modes that used in 5G networks to save power may be not needed in 6G because 6G will integrate machine learning for radio resource management. So this power saving mode may be not required. But it's just a guess. So we don't know. So maybe some that kind of features will be dropped in 6G. And spectrum allocation will need to accommodate legacy 5G IoT deployment. So there will not be much difference in terms of spectrum allocation. And IoT-centric features, essentially, we need to bring to the 6G time. Otherwise, this massive connectivity applications will have a lot of issues. So therefore, I can tell you almost backward compatible technique. 6G will be uh, such a technique. Okay, so I think I can conclude my webinar like this. So 6G will be will redefine connectivity with new applications and new capabilities. New key performance indicators will be there. They are mostly enhancement of 5G capabilities, and there are quite few new applications. And most importantly, integration of AI techniques and advanced spectrum usage, especially terahertz millimeter wave communication, how we can employ them in a efficient way, and also fully connected global network we are expected in 6G. So whenever or wherever you are there, your device should be connected any device that you need. So that is fully connected concept. And to achieve these things, we had a lot of technological advancements, techniques in 6G, like massive ultra massive MIMO techniques, and then cell-free technique, and reconfigurable intelligent surface technique, radio stripes, and new security shifts. And we understood many paradigm shifts, actually 4 paradigm shifts in 6G. So we have to integrate all the 4 networks, terrestrial networks, satellite network, maritime networks. And yeah, and then we discussed about research and standardization progress going with 6G communication. And yeah, finally, we expect 6G deployment in 2030s. Okay, thank you very much for listening to me. Hopefully my voice was okay. Yeah.
Yes, yes. Thank you very much, Dr. Anuradha, for your very informative and sort of inviting presentation with,
Yeah.
with very attractive short and sweet slides.
Yeah, actually, here there are a lot of research ideas, and still, I have to tell you, these things are not finalized yet. Even none of the specification in 6G. So still, we as engineers, as researchers, we have a lot of opportunities to work on these directions.
Yes, actually, I agree with you. Basically, as you mentioned in your presentation, if somebody says 5G is sort of a disappointment, we believe we have organized this webinar in high time just to prepare for the future with 6G by, I mean, sort of a relief to this 5G disappointments in terms of its expected performance and what actually available.
Yeah. Yeah, actually, we have like another 5 years to check whether 5G will be fully successful or partly successful. To check that one, I think it is too early to decide such a thing.
Yeah, exactly. Because when I was engaging with your presentation, what I understood, actually this 6G supports in a vast area, especially in intelligent transport, e-transport, and with those perceptible advancements you mentioned during your presentation, it supports, I feel, when it comes to my field, it supports heavily in intelligent controlling smart grids,
Yeah.
like that.
Yeah,
Okay.
actually, in smart grids, it is under the critical communication in 6G or 5G time. So you need the very low latency and you need very high reliable data. So
Exactly.
therefore, it's
And also
directly in the yes, you are a, let's say, region.
yes. As overall, I believe we have organized very fruitful presentation to the audience. Okay. So just to enhance its fruitfulness, now I would like to invite you all. Let's make this our Q&A session more interactive. Therefore, I would like to request from all the participants, please raise your hands and unmute yourself. Please, uh, please give your problem. If you have any clarifications or any questions to be asked from Dr. Anuradha, so please, I kindly request you to unmute yourself and uh, give your problem to the speaker. Yes, please.
Hello, can I come first?
Yes, sure.
Yeah.
Okay. Now my question goes to the speaker directly, but this is something now from your speech I understand, there is a huge delay in implementing the 5G technology in Sri Lanka. From your understanding, what is the reason? Is it due to the technological support or due to the financial support? Or something, is it something to do with the disappointing technology of 5G? Oh, what is the critical reason for that?
Yeah. So this is a very good question. Since even we have a lot of financial issues in Sri Lanka, but in terms of technological point of view, I don't think we are like behind the uh, Europe or United States. So we have very good engineers and very good technological support because we have very advanced, our graduates have advanced knowledge, but still this kind of new technological advancements are going to be delayed in terms of deployment. I guess one thing is this these for example, to implement 5G, the millimeter wave solutions, the current existing infrastructure may not possible to deploy such a communication scenario. So in that case, the financial issues is the main problem. Maybe Huawei or SETI or other vendors may not able to provide some equipments with low cost to the operators, and operators are not willing to spend that much of huge investment at the very beginning. So in that case, uh, and also this is a combination of all the reasons that you mentioned. For example, recently South Korea lost a huge amount of investment because millimeter wave communication is failed. So they didn't meet all the performance they expected. So then maybe the countries like Sri Lanka, so we are not, our operators may not willing to accept these things at once. So due to these financial issues and technological risk, I guess these deployments are delayed now. But I don't think once the 5G is in matured level, for example, in Norway, still 5G is not fully covered in all urban areas. Only in very hot areas is covered, but some rural areas, it's still 4G. So maybe the time, with the time elapsed, the countries like Sri Lanka will have opportunity to deploy 5G equipments, and the cost may be going to be uh, tolerable in the future for deploying 5G core networks. Uh, I think that is the reason. It's the integration of all the factors that you mentioned.
Okay, thank you. Thank you for the
Yeah,
your answer.
thank you. Yeah.
But the only issue is now, since we are already late by 5 years, now is it possible for us to wait till 6G comes and then go for a deployment rather than skipping the 5G? Do you think it is a good idea to do that?
I don't think it is. I mean, directly going from 6G without deploying 5G may not realistic, because this decade, 2030. So if by 2030, the Europe and United States start their 6G deployments, and they are willing to take the risk, whatever the terahertz communication deployment and all these things. And then this risk will be analyzed by our operators, and then they are going to, they cannot wait until 6G fully deployed. Then 6G, the risk is tolerated, and I don't think they will wait until that with 4G networks. Maybe they will transfer to 5G networks before 6G coming, during 6G era in the world. I hope our operators will transfer to 5G, because even though these generations are past, but these 5G applications will be emerged in our country. For example, IoT networks can be deployed for different purposes. I heard the current government try to digitalize some things, some domains in Sri Lanka. So in that case, we have to deploy IoT networks, which is supported by 5G. So then operators has to move to 5G. They may not wait until 6G is a promising solution for them. So in reality, maybe first 5G deployments, at least in the town areas. And then when it comes to 6G, maybe Colombo City can be covered with both 5G and 6G, I hope.
Engineer Alia, I believe Dr. Anuradha has adequately answered your questions.
Yeah, definitely. Yes, yes.
Oh,
Yeah, thank you for your
Yeah.
good question.
I request from the audience, if you have questions or clarification, this is the best time, this is the high time to direct those questions to our speaker or keynote speaker, Dr. Anuradha. If you have concerns, please take the maximum benefits.
Yes, Dr. Anuradha, one question from me.
Yeah.
That you mentioned that millimeter wave is not working well for the 5G, but we are looking for a terahertz communication to
Yes.
improve this performance. My question is that how that terahertz communication can help. Like in my view, like it is even difficult to manage than the millimeter waves because of the high frequency and lower coverage. So
Yeah.
how this help with in 6G?
So, yeah, I agree that millimeter wave communication, if it is difficult with millimeter wave, then how we can achieve terahertz spectrum to fulfill these requirements. So this is a very big research question currently researchers are tackling. I think, as I mentioned during my speech, we have to integrate different techniques with terahertz communication. For example, and also we have to, 6G or 5G will not expected to deploy terahertz communication as a general communication. So we expect that kind of communication only in, for example, hotspot areas to cover kind of Olympic kind of game, which thousands of people gather at once and need high-speed data, because thousands of people gathered in a stadium and they are sending videos, photos to their friends and exchangement. So these kind of things need at once, but for a short period, very high traffic demand. So in that case, we can use millimeter wave and terahertz communication with the integration of some advanced techniques such as beam alignment or radio stripes and cell-free massive MIMO techniques. So just using current 5G NOMA technique with terahertz communication will not give the best performance. The performance will be, we expect the current millimeter wave performance can be increased with enhanced machine learning techniques integrated with this beam alignment, beam steering techniques, where we can focus the target receiver with a very narrow beam by using machine learning. So therefore we need users location exactly and users movement, the dynamic changes of user location. So these kind of things are the challenges. But people have not removed this terahertz communication from the consideration. So they still believe with those techniques integrated with terahertz communication, they can achieve some performance in the future. And that is why there is a huge investment for this terahertz research project, which has started by EU. So I don't know, in the future, maybe depending on the pilot project success, they have to decide on this communication. But still, there is a huge spectrum remain in terahertz range, as we already know, and somehow we have to get the benefit of this available spectrum for some applications. I think, yeah.
Yeah,
So,
thank you, Dr.
yeah,
Dr. Anand.
yeah, thank you. Yeah.
I guess time permit for us to go for one more question.
Dr. Anprada.
Yes.
Yes, Engineer Sampath,
Yeah,
please go ahead.
yeah. Thank you for your very nice and detailed presentation. And
Yeah.
my question is still, I think energy efficiency will be key in 6G development. So, how how 6G can be balanced that high performance with energy efficiency?
Yeah. I can give you the answer in my opinion. So in 6G, most probably, I don't think the total energy consumption will be reduced than 5G. So definitely, I expect more energy consumption in terms of total energy in 6G networks. The energy consumption is increased from 4G to 5G because of this ultra dense networks. So we have to deploy many base stations and many antennas in massive MIMO. So those are the main issues that we had. So in 6G, we are going to increase these things more and more, like very large number of antenna stripes, and but with some modifications for the antenna coverage, and since these antennas will cover only a small area, maybe the power consumption per antenna will be reduced, but number of antennas will be increased. So even though per antenna power consumption reduced, but totally it will be increased. But we don't know whether we can control this high energy consumption by using machine learning. So I guess one of the main work or main target of AI in 6G will be to reduce this power consumption. So in that case, 6G will help to predict the user's behavior. According to the user's behavior, these antennas can be controlled in a coordinated way, because cell-free networks, this central processing unit can decide which antennas can be switched on and which can be switched off, and what kind of beam width the receiver need. So then when we narrow down the beam width towards a particular user, we can save a lot of energy waste. And yeah, so all these things depending on the machine learning performance in all these communication areas. So then I hope if machine learning will successfully integrated, then power consumption may be controlled, can be controlled than 5G. But 5G, since we don't have any machine learning integration, it's just our traditional way of doing power control. Like we are going to have a sleep mode for some time and then active. So likewise, we are going to control the power consumption, but not by any intelligent way, which will optimize the performance of the network. So I guess that is an important factor, machine learning.
Yes, Dr. Anurag, thank you very much. That means
Yeah,
that
thank you.
AI will play a big role in this area as well.
Yeah, definitely.
Thank you.
Okay, thank you very much, audience, for making this Q&A session more interactive by just directly directing your questions to our speaker. I think now we have come to the end of this session. But to formally conclude, I would like to invite our chair, Engineer Sahara Masuk to deliver the vote of thanks. Thank you.
Thank you very much, Dr. Konara. So it's a great privilege for us today, personally for me, to witness this spectacular online lecture from Dr. Indik Anuradha Mendis, because I have been a student of him at one point in my life. So it's a great privilege and an honor to have one of my own teachers from university to come and deliver a lecture when I have been appointed as the chairman of the sectional committee. So thank you, sir. Thank you very much for, despite your busy schedule, you have given a lot of thoughts for us to think about, especially being from in the power and energy sector. These things are always intriguing to me. Although my knowledge has not been updated much since university because I chose a different career field, but it always intrigues me, and I'm always interested to know what's going to happen in the future when it comes to communication, which is, I believe, a very important part of our lives now. 6 years ago or 5 years ago, you wouldn't have even believed that we will be having this kind of online webinar from having a resource person from a different country. But thanks, I think, due to the challenges after the COVID-19 pandemic, even people I think the Homo sapiens are very different species. They came out of different solutions, and this is one kind of solution. And I think even this kind of things can be we can take it to the next level if the communication technology is further improved. So I think I'm looking forward to the improved technology, 5G, 6G, and whatever the new technology the future is for us. So thank you, sir, for enlightening us on all these new technologies, new things. There are so many things that I realize that even I am out of touch, but that interested me today. So I wish to learn more about that, although I'm in a different field. So thank you again, sir. And we'll look forward to work with you again, if possible, in some kind of another similar lecture or CPD. And now I would like to take this opportunity to thank my subcommittee for public lectures head, or the chair of this subcommittee for public lectures, Dr. Engineer Southern Konara. Again, a privilege for me to work with my own, someone who passed out with me, graduated with me from the university, but I see him in a very different persona today. And I look up to him and respect him a lot. So thank you very much, Dr. Konara, for organizing these kind of fruitful sessions and getting the best out of best resource persons from all over the world. You're trying very hard, and I really have to take this opportunity to thank you as well. And also I have to thank committee members of this subcommittee, public lecture subcommittee. We can see Engineer Nuwan Ransakar over there. And he's also from Sri Lanka Telecom. And again, one of my matchmates, which I have to again say, it's a great privilege. And I really like to see that there were only around maximum 30 participants, but most of them were remaining until the end. And there were some very interesting questions from the audience as well. So my dear audience, fellow engineers, thank you very much for joining us despite your busy schedule. And you have also engaged and made this session all the more valuable for all of us. So finally, this opportunity was given by the Institute of Engineers Sri Lanka. I would like to thank them as well for all the arrangements they have done for us to share our knowledge from a resource person from all the way from Norway today. So let's get...
Thank you very much from my side. So I'm invited for this webinar from IESL. So I should thank all the IESL members and chairs of these committees, and especially Dr. Konara for giving this opportunity, inviting me for this webinar. And also all the participants, thank you very much for your insightful questions and your patience to hearing my webinar. So thank you very much.
Thank you very much again, sir. So with that, I think we can conclude the webinar for today, and we look forward to meeting with you again with another interesting topic and interesting lecture. Have a good night and good evening to Dr. Anuradha.
Yeah. good night for everyone.
Thank you, sir.
Yeah, see you.